It's been over a year since a nuclear-powered, one-armed, six-wheeled rover called the Perseverance punched through the Martian atmosphere at a blazing 12,000 miles per hour, and a supersonic parachute slowed it way down until a rocket-powered jetpack could fire its engines and then gently lower it onto the surface. Since that fateful day, the rover has been hard at work studying the Martian surface in an attempt to find signs of life. Let's look at the newest mission the rover has undertaken to finally prove the existence of life on Mars. Perseverance is far from the first rover NASA has sent to the Red Planet to search for signs of ancient life. Almost 50 years ago, NASA sent a pair of landers to Mars, marking the first U.S. mission to successfully touch down on the planet. This project was then followed by the Viking mission. Launched in 1975, this ambitious mission was tasked with looking for current life on Mars, but came up empty. The mission served as a harsh lesson to scientists on Earth. The ambiguous data collected taught us that we needed to better understand the surface and potential habitats on Mars. Follow-up missions of orbiters, landers, and rovers looked to see if Mars was even habitable to begin with. They focused on searching first for signs of ancient water, a key to life as we know it here on Earth. Rovers like Spirit and Opportunity launched in 2003, and Curiosity, launched in 2011, provided the groundwork for Perseverance to begin searching for ancient microbes in the rocks and dirt on Mars. One of the first assignments for Perseverance was to search an area on Mars called the Jezero Crater. Scientists believe this might have been an ancient lake fed by a flow of Martian rivers at some time in the planet's past. Over the last few months, the rover has made its way toward a river delta located at the edge of the crater. Life as we know it requires a habitable environment to thrive and exist. The assumption is that life on Mars would need water as a universal solvent, much like life here on Earth. This is the primary reason why finding environments on Mars where water flowed in the past is crucial for conducting studies and looking for signs of ancient life. Much like river deltas here on Earth, scientists expect to find layers and layers of rich geological history trapped in the sediment, a prime spot for drilling samples that might have trapped evidence of past Martian life. Confirming the existence of ancient life on another planet would be an extraordinary finding, which would require similarly extraordinary evidence to prove. One of the most effective ways of confirming these findings is to collect samples on Mars and have them returned to Earth for extensive examination. The Perseverance is equipped with drills and sample tubes and has already begun collecting bits of Martian rock. In its first year, it has collected and stashed 6 samples, with the ability to collect up to 40. NASA and the European Space Agency are working together to develop a mission to collect those samples, launch them off the surface of Mars, and safely return them to Earth. The agency awarded Lockheed Martin a contract to develop the Mars Ascent Vehicle, which will be the first rocket to launch a payload off of another planet. But other pieces of the mission's architecture are still in the works. If all goes well, scientists could have their hands on Martian rocks in 2031. While scientists wait for Perseverance to collect Martian samples, the mission is breaking ground in other ways. A tiny helicopter stowed away on the belly of the rover has completed more than 19 successful flights on the surface of Mars. What started as a proof of concept with major concerns if engineers could even design an aircraft that could fly in Mars' thin atmosphere is now helping the rover spot new places to explore. The helicopter can fly over areas that are too rugged for the rover to traverse. This allows scientists back on Earth to see high-resolution images in areas the rover can't reach. One of the biggest targets for Ingenuity to help the rover navigate has been mapping a geologically rich river delta where scientists hope to peel back layers of Martian history written in the rocks by ancient water. Over the last few months, the rover has started its journey to this area, with the helicopter flying ahead to scope out a safe path. But like all good things, eventually the helicopter will come to an end. While it hasn't shown any signs of slowing yet, the parts on the tiny aircraft will eventually give out. The instrument has already surpassed expectations and has flown more missions than it was designed to undertake. Recent reports have stated that the Perseverance is finally on the last leg of its journey to the ancient crater, where it will collect more samples for study. It will roll uphill, stopping every so often to examine rocks that look to have the best chance of retaining evidence of past life on the planet. On its way back down, Perseverance will collect some of these rocks, placing the samples at the base of the delta to be retrieved by later missions. The goal is still to bring this material back to Earth sometime in the 2030s for detailed inspection. Scientists have stated that the delta in Jezero crater is the main astrobiology target of Perseverance. The rocks in the crater are likely to have the highest potential for containing signs of ancient life and will also help explain how the climate of Mars has evolved over time. Since its landing last year, the rover has been testing its tools and instruments while gathering a general impression of its new surroundings. But the robot's chief purpose in going to the near equatorial bowl on the red planet has always been to study the huge mound of sediments in the west of Jezero. Long suspected to be a delta, based on satellite imagery, Perseverance's initial observations on the ground have now confirmed this assessment. A delta is a structure built up from the silt and sand dumped by a river as it enters a wider body of water. The sudden deceleration that occurs in the river's flow allows anything carried in suspension to fall out. In Jezero's case, the wider body of water was very probably a crater-wide lake that existed billions of years ago. In recent days, Perseverance has maneuvered itself to an on-ramp to the delta dubbed Hawksbill Gap. This is a gentle incline that will take the robot to an elevation of a few tens of meters above the crater floor. Thanks to this ascent, the rover will be able to survey its surroundings to look for enticing delta rock samples. The rover is equipped with amazing instruments that can tell scientists about the chemistry, mineralogy, and structure of the delta by examining the sediments down to the scale with a grain of salt. This will help us learn about the chemistry of this ancient lake, whether its waters were acidic or neutral, whether it was a habitable environment, and what kind of life it might have supported. As of yet, no one knows if life ever got started on Mars, but if it did, the 3 or 4 rocks Perseverance chooses to drill and cache on the way back down to the crater floor could be the ones to tell us. It's unlikely the robot itself will be able to make any definitive statements, as smart as its instruments are. Even on Earth, where we know microbial life has existed for billions of years, the evidence of its earliest fossilized forms is hard to interpret, even contentious. Establishing the facts of life on Mars will therefore have to wait for the rover's rock collection to be brought home for the type of rigorous investigation only the biggest laboratories are equipped to carry out. Perseverance is expected to put down its first rock stash when it returns to the crater floor at the end of the year. This depot will comprise not just those rocks gathered during the Hawksbill descent, but 4 samples collected in previous months out on the crater floor. NASA, together with the European Space Agency, is in the advanced stages of planning the missions required to go and retrieve the depot. These ventures, which will incorporate another rover, a Mars rocket, and carrier spacecraft, should be launched towards the end of this decade. Perseverance has plenty more years of work ahead of it. After it has put down its first rock stash, it will drive back up Hawksbill Gap to the very top of the delta and beyond to visit rocks that look like they could be the remnants of the shoreline to the ancient Jezero Lake. These deposits are made of carbonate materials and again look to have formed in a setting conducive to the recording of past life, if ever it existed. If you like this video, you may also enjoy this one, which looks into the various discoveries that have been made on Mars over the decades. Do you think Mars supported ancient life? Please share your thoughts in the comment section below.